Hello, my paper is Differentiable Learning of Logical Rules for Knowledge-Based Reasoning. Essentially, what this paper does is it uses something known as neural logic programming to learn logical rules, and it uses these learned logical rules for knowledge base or knowledge graph completion. So, what uh, neural logic programming does is it learns these rules in an end-to-end differentiable model using a differentiable logic called TensorLog. At a very high level, TensorLog essentially treats each entity, uh, it assigns an integer number to each entity, and it represents each entity with a one hot encoded vector, and it represents each relation as a matrix where the matrix of I comma j value is equal to 1 if and only if those entities I and j are related. It uses a set of matrix multiplications and vector calculations and differentiable operations on these matrices to learn the logical rules, which are then used for knowledge-based completion. The input to this model is basically a graph or ontology, a set of entity relation entity triples, and the output is a set of predicted entity relation entity triples. The evaluation datasets used, the first two were decided for our entire group, WordNet 18 and Freebase 15K. And the third one is a more selective version of Freebase 15K called Freebase 15K Selected. It's also known as Freebase 15K 237. The evaluation metrics used was HitSet 10, mean rank, and mean reciprocal rank. The following screenshot is for um, a subset of the WordNet 18 database, and the metrics are shown as in the figure. Moving on to the code, the implementation is for a kinship data set, which just for representation purposes, since it's a much smaller data set and it can run in a short amount of time. So essentially, here initially the path provided is to the main directory, which contains the subclass file which has the refactored code as well as the main.py file. Then we create an object of the neural LP class. Next, we provide the path to wherever the datasets folder is. The datasets folder needs to contain a train um, test facts and valid.txt files, which contain these entity relation entity triples. Um, then we send this path to the read.dataset function, which reads it, and then we train the model, and then we perform predictions on the model. So as you can see, the data has been prepared and the option is saved here. And now we start the training. And then the testing is also performed. And for the final evaluation, we use a getTruths method to which we pass the same datasets folder, which contains all the required files, and then we call the evaluate function on that. This provides a final evaluation metrics. And as you can see, the HitSet 10, mean rank, and mean reciprocal rank metrics are provided. Thank you.